Alrighty, so we're just gonna go over the quizzes that we did for our homework last time, seeing what questions might have been more difficult, just going through answering what kind of things we're gonna, what the answers are. Preparing ourselves for. No, I didn't mean to watch polling. Okay. So I starts at 100. We're going to repeat until I equals 0. So remember, this is going to do exactly what it sounds like. It's going to keep looping as long as this condition is false. Which of the following replacements for missing code will cause an infinite loop? Repeat until I equals 0. I equals I mod 2, I equals I mod 3, I equals I mod 4, I equals I mod 5. So let's just kind of let's do some calculations. 100 mod 2 does equal 0. So that won't be an infinite loop. 100 mod 3, it's going to give us 1. Because 3 goes into 111, not 11, 22 times, 30, 33 times? Yeah, 33 times. I can do math. So we get 99 with a remainder of 1, and then 1 mod 3 gives us 1 mod 3 gives us 1. That looks like it'll cause an infinite loop. 100 mod 4 and 100 mod 5 are both going to equal 0. So our infinite loop will be caused by mod 3 because it doesn't divide evenly, and there's no way for it to get to a point where it does divide evenly. Which of the following replacements will not cause an infinite loop? I equals 0, repeat until I equals 100. So we've kind of flipped those. I equals I over 2. Is that going to get I any bigger? No, I is going to stay 0. When we divide by 2, it's going to keep on equaling 0. Same is true I mod 2. 0 mod 2 equals 0. It's never going to hit 100. Same is even true with times 2. That's going to equal 0 forever. So the only one that won't get us an infinite loop is that I equals I plus 2. A bank uses a computer program to tell if the alarm should ring. Sensors in the bank set the following Boolean variables. Vault closed is set to true if the bank vault is closed, otherwise false. Heard noise is set to true if the microphone heard a noise, otherwise it's false. And saw movement is set to true if the camera saw a movement, otherwise it will be false. The automatic alarm should notify the police if there's noise and movement in the bank, or if the vault is open. Which of the following Boolean expressions can be used in selection statement to ring the alarm? So we want noise and movement. So looks like that first one has heard noise and saw movement. And we want to check if the vault is open. So we know that vault closed will be true if the vault is closed. So we want it to be false. So not vault closed seems like it will do that. Not vault closed or heard noise and saw movement. That seems like our correct answer. It's got all of the components we're looking for. A farmer is considering planting a new crop of beans. Sensors in the farmer's fields report the following Boolean variables: soil wet or soil dry, and soil cold and soil warm. Essentially kind of just opposites of each other, but beans should only be planted when the soil is warm and wet. Which of the following Boolean expressions can our farmer use if she wants to plant beans? If we see an and here, we kind of disqualify both the answers with an or. and we want soil to be warm and wet. So soil wet and soil warm. There we go. It's pretty straightforward. I equals 1, repeat until I is greater than 100. Which of the following replacements for our missing code will print all odd numbers from 1 through 100? I equals 1, I equals I times 2, display I. That's going to get us 1, 2, 4, 8, 16. That's not going to get us odd numbers. I equals I plus 2, display I. That will get us 1, 3, 5, 7. Actually, will that get us 1, 3, 5, 7, and 9? If we add 2 first. Actually, won't show that 1 at the beginning. So it'll get us up until 100. Or I guess to 99. But we're missing that 1. So we don't want to increment before we display. We want to display I and then increment. So that will give us that missing 1, and then increase to 3, increase to 5, and so on. So there is our correct answer because of sequencing. We want display to happen first rather than the addition to happen first. So the following code segment, I equals 1, repeat until missing condition, I equals I over 2. Which of the following replacements for missing condition will not cause an infinite loop? I less than or equal to 0, I greater than 1, I equals 0, I less than 1. Is it possible for our value to reach 0 in this code? No, because we're going to get from 1 will become 0.5, will become 0.25, and so on. It's going to become smaller and smaller decimals, but it's never going to hit 0. We're also similarly never going to get any bigger, so both of those are disqualified. We already said we can't hit 0, so as long, or we're going to loop until I is less than 1. We're only going to loop once, but that is going to give us our answer we're looking for. Consider the following code segment. I equals 1, j equals 0. Repeat until some missing condition. J equals I equals I plus 1. So let's just do a couple of loops. J and I. J starts at 0, I equals 1. So J gets 1, I becomes 2. J becomes 2, I becomes 3. J becomes 3, I becomes 4. So that's how our pattern's going to look. Which of the following replacements will cause an infinite loop? I greater than or equal to 1,000. I think if we keep going, I will eventually hit 1,000, so that won't cause an infinite loop until j equals 1. J equals 1 right here, so that won't happen. Until j is less than I think that's going to be true every single time we check that condition. So that'll never be right. Yes, that'll be true the very first time. So we'll actually never even loop. So that won't be infinite. But we will never stop looping if our condition is j equals I, because we're going to check that condition after we've updated I to be I plus 1 again. So even though j and I equal each other at this point, we don't check the condition then. We check the condition here when j and I have both been updated. So I equals j as our condition will cause an infinite loop there. VCHS department at a university is using the following program to determine the average GPA of the department on a 4-point scale. Unfortunately, some of the data was entered incorrectly, and values greater than 4 exist in the system. The department determines that if a student's GPA is greater than 4, it should be excluded from the average. The students' GPAs are stored in the list of student GPAs, which is indexed from 1 to n. Grade point average sum equals 0. Num GPAs is equal to the length of student GPAs. I equals 1. Repeat n times. We've got some missing code. Display grade point average sum over n. Now, I assume that here they wanted to actually say num GPAs. Because the question doesn't make very much sense if we don't use num GPAs there. All right, dropping stuff all over the place. So, which of the following code segments can replace missing code so the program works as intended? If student GPAs at index I is greater than or equal to 4, grade point average sum equals grade point average sum plus student GPAs at index I. Is that what we want to do? If it's greater than or equal to 4, add it? No. So we can disqualify that one. If student GPA at index I is less than or equal to 4, grade point average sum equals grade point average sum plus student GPAs at index I. That seems good. Else num GPAs equals num GPAs minus 1. That also seems good. We're reducing the number we're averaging. And then we increase I by 1. So let's actually move down slightly and select this stuff and put it back in the right spot. Okay, so this one seems pretty good. If student GPA is less than 4, seems decent, then add to the sum and then increase I by 1. Now, the reason we got this one won't work is because we only increase our I if we correctly got something. So if our very first thing was a 5, our very first thing in the list was a 5, then I is never going to increase. We're going to subtract 1 from our number of GPAs forever. So this one is disqualified because we need to increase our I each time in the loop. And if student GPAs at index I is greater than 4, we already said we don't want to do that. Here, it's adding the value and subtracting 1 from our number of GPAs, which is definitely not what we want to do. So this answer is our correct one, does all of our things properly. All right, so the following code statement. I equals 1, counter equals 1. Repeat until missing condition. Display I equals I times 2, counter equals counter plus 1. Which of the following replacements for missing condition will display the first 10 powers of 2, starting with 1 as the first power of 2? So we want I and condition. What are our first 10 powers of 2? 1, 2, 4, 8, 16, 32, 64, 128, 56, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 5, 12. Is that 10? I think that's 10. Yes. So condition, or counter, that's not, that should say there. Counter starts at 1, and we add 1 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to repeat until this point. So do we want to repeat until I is greater than or equal to 100? Will that get us to those 10 outputs? No, because that would stop us here. So it's not that one. Until counter is greater than 10. I think that's going to loop one extra time to 1024 when counter is 11. So we don't want that. Until counter equals I times 2, given the rate that these two variables are changing, I don't think it's ever true that counter is going to equal I times 2. So definitely not that one. So we want to loop until counter is greater than or equal to 10. As soon as we hit 10, we want to stop. Is that right? I think right. Yeah. Chat. Does the answer for B is actually number 9? Okay, that's probably because I did my math wrong. I think since counter is changing inside the loop, so at the end of we're going into the loop here. I equals I times 2, counter equals counter plus 1. So we display the previous value for I, and then we multiply times 2. So we display that. Okay, yes, it would definitely, I apologize. Sequencing, I did not take it properly into account. So we're going to display the previous value for I, and then increase counter and our I value. So we're not actually going to display 512 until counter is 11. So if we stop when counter equals 10, we will only have printed 256, which will not have printed all the values we were looking for. Thank you for pointing out my error. That is, yes, that is correct. We want to loop until counter is greater than 10. So when counter hits 11, then we'll actually have printed 512 and we can exit. So keeping track of sequencing is important, and I did not do it very well that time, so I apologize. All right, next question. A construction company is using the following program to find out how much concrete is needed for a building under construction. The list all floors contains the number of square feet for every floor in the building. The construction company knows that if the square footage of each floor is multiplied by 3, the sum would be a rough guess at how many kilograms of concrete will be needed. Assuming that all floors is a list of square footages for each floor, which of the following procedures would not make the program work as intended? Total concrete equals 0, I equals 1, repeat n times. Total concrete equals total concrete plus all floors at index I equals I plus 1. Display total concrete. Is there any multiplication by 3 happening here? Doesn't seem like there's any multiplication by 3 happening. So I think that that's our wrong answer from the get-go. That would not work as intended because we're not multiplying by 3 anywhere. If we look at the other ones, we are repeating or doing that same thing, except we're multiplying that all floors at index I times 3. And in this last one, we're doing a for each loop. Actually, I guess in each of these ones, we're doing a for each loop. Here, we're multiplying the individual floor by 3. Here, we're multiplying the total concrete by 3. In either of those scenarios, that's still going to work. We're still going to multiply by 3. So the only one where we're not is option number 1, which means it's incorrect. It will not work as intended. So the following code segment, I equals 1, repeat until, missing condition, I equals I plus 5. Which of the following replacements will not result in an infinite loop? I less than 1, I equals 5, I equals 11, I equals 0. So is it possible for I to be less than 1 when it starts at 1? No. So that will give us an infinite loop. Is it possible for I to equal 5? 1 plus 5 equals 5. Wow, 1 plus 5 does not equal 5. That equals 6. Promise I know how to do math. So that will enter an infinite loop. I is never going to equal 0, going up each time. But 6 plus 5 does give us 11. So I equals 11 will not result in an infinite loop. So if we repeat until I is 11, we'll be good. All right, I equals 3, repeat until missing condition. I equals I plus I. So we start with 3, we go to 3 plus 3 is 6, 6 plus 6 is 12, 24, 48. So let's look at those things. Repeat until something. We want to get an infinite loop. Until I equals 9, until I less than or equal to 12, until I is greater than or equal to 50, or I equals 24. If we look at our sequence, we were less than 12. Our next step would definitely be bigger than 50. And we definitely did equal 24. So the only one that we will not see is I equaling 9, because that would have happened kind of in the middle here if it were going to. So I equals 9 is our answer. It will never hit that. A machine is used as a local post office to separate local mail from non-local mail. The machine can move between 2 buckets marked local and non-local and can deposit pieces of mail in each. Sensors on the machine are used to set the following variables. Local mail is true if it's local and false otherwise. Non-local mail is true if it's not local and false otherwise. I feel like these 2 variables are a little bit redundant because these are always going to be opposite each other, and these are always going to be opposite each other. But whatever. At local bucket is true if we were at the local mail bucket, and non-local bucket is true if we're at the non-local mail bucket. So we need to move the opposite bucket when we have a piece of mail that does not currently correspond to the bucket we're currently at. So which of these will tell it to move? Local mail or at non-local bucket, or non-local mail or at local bucket. I think so. Our situations are, we have local mail over the non-local, where we have non-local over the local bucket. So in order to move, we need one of those 2 situations to be true. So it needs to be have a local mail and be at the non-local bucket, or have non-local mail and be at the local bucket. So we want an and between those. And either one of these can be true if we want to move. So we want an or there. So we want an and inside of our parentheses, local mail and at non-local bucket, non-local mail and at local bucket. Those are our 2 circles here. And then or, if either one of those is true, then we will move. So there is our answer. Consider the following code segment. I equals 0, repeat until I is greater than 10, missing code. Which of the following replacements will result in the numbers 1 through 11 being printed to the screen? Nothing is being displayed here. Nothing is being changed here. So we can disqualify both of those. And here we have 2 options, and it's a question of sequencing. Since I starts at 0, if we want to actually display the number 1 first, 1, 2, 3, down through 11, we want to make sure we update our value for I before we do our display. So this is our correct answer, because otherwise we would start at 0 and go up through 10. And that was the last question. Our other quiz was the programming style, and this one's just a bit more theoretical questions. Which of the following is true about why it is important to write clear function names? The name changes how the program functions. That's not true. I'm not drawing. The name makes it clear what the purpose of the function is. That seems true. The name allows you to translate the program into other languages. Not really. And the name of a function is only used by the computer. Also, not really. So the name does make it clear what the purpose of the function is. That's true. Which of these is not one of the components of programming style? Variable names, function names, documentation, or random numbers? Definitely random numbers. Those aren't part of the style that we use for our code. We're naming things and creating documentation for our code definitely are. You are writing a program that needs to use a variable to say the speed of a car. Which of these variable names would be unclear in terms of programming style? Car speed, vehicle speed, variable value, or speed? I feel like this one's pretty straightforward. It's the only one that doesn't really have anything to do with speed. Variable value. It's very unclear what that is supposed to hold. Why is it important to focus on programming style in addition to programming functionality? Programming style helps others understand your program and maintain it. It only applies to certain programming languages, or it increases the reusability of your code. Well, options 1 and 3 both seem very true, where option 2 is absolutely false. No matter what language you're programming in, your code should be written in such a way that it is easy to understand. So 1 and 3 are going to be our answers. And what are reasons you may write a comment near a variable or function? The comment could explain important assumptions about a variable. The comment might give conditions that need to be valid for a function to work properly, or the comment could let you know what line of code you're on. I feel like number 3 isn't super helpful. You just look at your editor and it'll probably tell you. And even then, it's not super relevant to know what line of code we're on. So 1 and 2 are definitely true. 3, less so. So there are our questions for today. Let's stop our recording.